This lesson introduces for loops, which allow repetitive tasks to be automated in code. It also introduces the range function, which generates a sequence of values for use in a for loop. Finally, we will see how for loops are nested to iterate across multiple dimensions of a dataset. This lesson introduces for loops. For loops are really important in practice because they allow us to implement repetitive calculations without lots of copying and paste. They also allow us to compute things over an arbitrary number of iterations. So I'm going to start by opening the lesson 11 notebook in Visual Studio Code. And I'll run some cells just to show what the text says. So the first assignment asks us to write just a really basic for loop that's going to do one thing. It's just going to use a loop to sum the numbers between 1 and n. Of course, we have an analytical formula for that. We know that it's just n times n plus 1 over 2. So we wouldn't in practice use a for loop, but this is a really easy way to describe the elements of a for loop. So we're going to start with an n. Again, I'll just leave that as 10, but we can change that later just to make sure it works. And then I want to have my for loop. So the structure of a for loop in Python, the basic structure, starts with for. Then you're going to have a variable that's going to be the variable that's going to be changing values. So I is a pretty common choice here. Then you use a reserved word in. So we say for I in. And then if we want to iterate over a range of numbers, say 1, 2, 3, 4, 5, numbers like that, we use another keyword called range. And range takes 3 parameters, although in most implementations you'll always use 2, start and stop. In this case, I want to sum the numbers 1, 2, 3, all the way through, including 10. So I need to get the first number I want is going to be 1. The last number I want is going to be 10. So it'd be tempting to think range 1, 10. That's not correct. In fact, I need to use range 1 to 11. The reason for that is very simple. Range will give me all I for start less than equal to I, strictly less than stop. So if I got my LaTeX correct here and I run this cell again, you'll see just the mathematical version of what I just said. So it gives me all I that are greater than or equal to start. So start is included, but stop is excluded. So to make this loop really clear here, I could say 10 plus 1, which will make it obvious that it's going to end at 11. The last value it gives will be 10 because it doesn't actually include 11. The third argument step allows you to iterate across ranges that don't have an increment of 1. And most of the time, we're going to want 1. So now that I have the start of my loop, I have for I in range. The second thing we have to be really careful about running loops is that Python is white space sensitive. In particular, the loop, all the code that's going to be looped across has to be indented with the same level of indentation. Typically, that's 4 spaces. So here I can count them. 1, 2, 3, 4 spaces. So any code I want to have here, this is obviously not correct code. Line 2, line 3, line 4, and so on. So all of that would be in the for loop. And then if I exited the for loop, I say print total. I'm going to define the total variable in just a second. I'll just define it now. This is going to be my sum that I'm going to count. So all of the lines that are indented with the same level of indentation are in the for loop. And when I decrease the level of indentation, particularly I return back to the same level as the start of the for loop, that actually tells Python that the loop is over. So this white space sensitivity is one thing you have to get a little bit used to in Python. And again, it's different from other languages that use braces, for example, any C dialect, C or Java, or use keywords like end to indicate that a loop has finished. So now that I have my basic for loop, again, this loop is just going to give me the values 1, 2, 3, all the way through 10. I just need to total equals total plus I. Python has a shorthand notation. I could also write total plus equals I, which does the exact same thing. And that's just going to add each value I to total starting at 0. If we run that cell, we should see 55, which we could easily think of, verify 10 times 11 divided by 2, 55. And so that is the structure of a basic for loop. Moving on to the next problem, it asks us to compute a compound return. So a compound return is what you get if you invest at a fixed interest rate for a particular length of time. So after 1 year, I'm going to have 1 plus r. After 2 years, I'm going to have 1 plus r squared. After 3 years, I'm going to have 1 plus r cubed. Again, there are better ways to do this, but this is just a really simple problem we can use a for loop to demonstrate. So I want to do it for 10 years. So again, I'm going to do for I in range. And this time, I just want to actually loop over 10 different increments. So I'll just go from 1 to 10. And I'm asked to store this in a vector CR. So I'm going to have to import numpy to get access to a vector. I'm going to do np.array. After I'm going to do np.zeros. This is a command that gives me an array that's pre-initialized to have all zeros. And then I tell it the shape. In this case, I want it to have simply 10 elements. So CR is going to have that. The other thing I need to keep track of is obviously my first, after 1 year, the cumulative return, it's not 0. So I need to actually set that. So I'm going to set CR 0 equal to 1 plus R, and I'll just define a variable here, R equals 0.05, so say 5%. We also want to look at the value of 100 pounds invested. So I need to multiply this times 100. So this is what I'll get in my very first year. So after 1 year, I'll have 1 plus R. Because I've already computed the first year, I don't want to repeat that calculation. So I'm going to go into my range, and I'm going to say, let's start at 1. So let's exclude the 0 observation. So range, like everything in Python, is 0-based. So the first value you get of range, if you just included 1 input, is stop. It is going to be 0. The next one will be 1, and so on. So I don't want to refill 0. So now that I have my range set up for to go from 1 to 10, not including 10, so in other words, 1, 2, 3, all the way through 9, I can type CRI equals 1 plus R, and we'll use parentheses just to make sure this gets calculated first, times CRI minus 1. So this is in practice a really important structure. This is a recursive loop where the current value depends on the previous value. When you set these recursive loops up, again, you got to be very careful not to start at 0, because if you start at 0 and you recurse to -1, you're actually going to get the wrong result. Python does support -1 indexing, which gives us the last value in our array or list, and that's completely the wrong thing. You'll get the wrong answer, and so you'd be a little bit careful not to do that. Okay, so now that I'm happy, I'm just going to print CR, run the cells, and that's what you get. You know, if we just want to verify the last value, we could just type 100 times 1 plus R, raise that to the power 10 using the star power operator, and we get the exact same number I have at the end of my array. So that's a little bit more complex array that uses a little bit of recursion, but it achieves the same thing. We're now getting into more realistic and somewhat more complicated arrays, or more complicated loops. So we're going to simulate a random walk. So a random walk is like prices, or asset prices are often thought to random walk. Random walk is a highly persistent process where every shock continues to remain in the process forever. So random walk, we're going to need some normals, some shocks for our random walk. The command is actually given here, which is I'm going to use np.random standard normal. need to tell it how many shocks I want. So you can be a multi-dimensional array of shocks. It could be have a number of rows, number of columns. In this case, we just want 100. So I'm just going to assign that to E. And those are going to be my shocks. If I want to, I could just print the first few observations of E. And we'll see it's going to look like random numbers. So these look like normal random numbers, positive and negative. But now that I have that, I can simulate my random walk. So I'm going to want my random walk is going to be, I'm going to call it Y. Again, I'm going to use NP zeros to give me an array of zeros. It's going to have 100 elements. And then I want to loop across I want to loop and do a recursion. So I would do for I in range 100. The colon at the end of my for statement, you always have to have that. Then I want yi equals yi minus 1 plus ei. So in other words, the current value of y is equal to the previous value of y plus ei. And I'm almost done there, except again, I got to be careful. I don't want the first value. So I can't sort of say y0 equals y0 minus 1 or y minus 1 plus e0. That'll give you the wrong answer. So then I need to just manually set y0 equal to e0. So I set the first y equal to the first shock, and then I do that. There are better ways to do this, again, using NumPy functions, but this is just a demonstration to sort of show how we actually use the loops. We're then asked, so I can go ahead and run that cell. We're not going to get the output because there's nothing to show, but we can then do a little bit of plotting. So I've just sort of given you the code on the right side of how to actually plot this. Cover plotting in a later lesson. I'll just copy and paste that code in, and I'll run the cells. And there is an example of a random walk. Obviously, every time you run this right now, we haven't done anything. Sorry, if I run the shocks again and I run the random walk and then I run the plot, you'll actually get a different plot. The shocks are pseudo-random in that they don't repeat. And so getting another set of shocks will give me a different random walk. So the one you get will almost certainly be different. Later on in the course, we'll describe how we construct reproducible random numbers so that if you run the code 2 times in a row, you'll actually get the same set of shocks. That's a bit more of an advanced topic. And so we don't need to cover that right now. So the final topic we're going to talk about are nested for loops. So a nested for loop occurs when you want a loop inside a loop. So again, these are pretty common. They're pretty common things. So if you want to actually, have loop across, loop down an array and also loop across columns, for example, rows and columns, that's one reason you get them. You want to loop across multiple variables. There's lots of reasons you have nested loops. So in that case, we're going to have an outer loop and then we're going to have an inner loop. So we just take a look at the problem. So we're talking about current value of investing £1 and getting the return of the momentum portfolio. So this will just, what we're going to do in the end is we're just going to construct a recursive set of cumulative returns you get for investing in the various momentum portfolios. So I have a setup block here, which I'm just going to run. And that's going to load some data. So this is the momentum data. We'll cover importing data using read CSV in a lesson, just a few lessons. But for now, I'm just going to print the head, and we'll see the structure. Oops, sorry. I turned it to a NumPy array. I used 2 NumPy, so I actually have a NumPy array. So I'm just going to say, give me the first 10 rows. And there you go. So you have 10 columns and many rows. It's 2 years of data. So you have many daily returns. So now what we want to do is we want to use a 2-dimensional loop to compute the cumulative return for each asset. So we want to get the cumulative return for each asset. So I need to start out with my cumulative returns. So I'm going to have CR. So I need an array of zeros, but how big does this array need to be? Well, I need to find out how many returns I have. So one way to do that is to get the number of observations is equal to momentum shape. So shape will actually have two elements, one for the number of rows, one for the number of columns. So I want the number of rows. I know the number of rows is going to be the first element. So I could then say I want zeros with num obs, but then I need 10 columns. In fact, if I wanted to, I could actually just use the fact that knob shape, sorry, not knob, excuse me, momentum shape is going to give me the number of rows and the number of columns. So we can see it's 503 rows and 10 columns. And then if I want to simplify this, I could actually just say momentum shape. There's an even easier function, which is np zeros like, which will basically do exactly what I had in the previous line. That is, it will essentially get the shape and it will make a set of zeros like the data that I have. So I'll go ahead and use that one. And again, this is just going to, if I run it, this is going to give me an array of zeros. So now I'm going to have two indices. So I'm going to need two loops. So for I in range, so we can go either way first. So I'll go across columns. So we're going to have 10 columns. And then I need for j in range. And again, I need to be careful there. How many I'm going to do time series? We see there's 503 observations. I could do, start at 0, 503, but again, I have the same problems I've had in the previous loop, so I'm going to have to start at 1. And then I'm going to want CR, row j, column I, is going to be equal to CR, row j minus 1, column I, times 1 plus momentum j comma I. So again, what this row is going to do here is going to say the cumulative return position j column I is the previous cumulative return, j minus 1, times 1 plus the current momentum return. So you can see the momentum returns are small numbers. They're way less than 1 because they're obviously already in percents. And that's almost got me. But again, I still have this problem with the first loop. So I need to set CR 0. So this is the entire first row. It's going to be equal to 1 plus momentum 0. So what that's going to do, it's going to say set the first cumulative return equal to 1 plus the first momentum return. So that's actually the return I would have if I invested £1 in the momentum portfolios, essentially in period, the first period that isn't actually in my sample. So this is a nested loop. The other thing that's important here again is, so obviously the first loop, I have an inner loop, so I get one level of indentation. When I have the interior loop, you can actually, there's two levels of indentation. So there's actually 2 blocks of 4 characters. That actually tells Python that we're in the inner loop. I could have more lines here, line 2, line 3, and so on. And in fact, I could return here for more lines here. Again, these obviously aren't code lines, but you can see what's going to happen here is, and obviously it's going to execute this line inside my inner loop. It would actually execute line 2 and line 3 in my inner loop. And then once the inner loop completed, so the end of after 503 has been, after it's looped across the range 1 to 503, it will actually go here and do these outer lines, and then it will finally return an increment I to its next value. So nested for loops, again, they're going to use white space and indentation in particular. And this is one thing that is a little bit different to Python that many of you will not have seen if you've ever seen programming. So it is a bit of a gotcha when you first get started. Most of the editors are pretty good about giving you some feedback about if something looks fishy. But, if you do have it indented wrong, for example, if I wanted these to be inside my inner loop and I don't indent them, then they won't be in the inner loop. So I need to put them back there. So I'm going to go ahead and delete these because I don't want them. I could run this cell. It's going to run without telling me anything. And then we're asked finally to plot them. I have a blank cell here. So I can do plot and CR, and I can just run that cell. And you can see those are my cumulative returns. So over this 2 years, it was quite a good period. So the highest one had cumulative returns of nearly 50%, or sort of almost 60%. So this is obviously this was 17, 18, I think, data. So it was very good, or maybe 16, 17 data for US. So it was overall a very good period. So even the sort of losers had a good period. But there is some spread in these returns that one of the portfolios had, a very modest 20%. Well, that's actually a very good period for 2 years. But the best one had a 60% increase. And of course, the base of the momentum trade is actually buying one that you hope is near the best and selling one that is near the worst and making a profit based on the difference. So finally, in this lesson, there are a few exercises that you can try to do just using a few different commands. One asks you to look up this command cumsum. Cumsum is actually a really simple way to simulate a random walk that saves you from having to write a loop, but that's left as an exercise.
This lesson introduces for loops. There are a few things to remember about for loops. First, they start with the keyword for. They always use the structure for iterator in iterable and have to end with a colon. In is also a reserved word. Iterator is usually a variable, something like I or X, and it's going to be a value you want to use in the loop. Iterable, in most cases we're going to see, is going to be range, which is simply a method to generate the numbers 0, 1, 2, 3, and so on. In general, range takes two parameters, start and stop. It's important to remember that range iterates between start, which is included, and stop, which is excluded. So if you wanted to generate a range that had the values 1 through 10, you would need to use range 1, 11. Finally, it's common to use the syntax range stop, which is equivalent to the syntax range 0, stop.